Hello, you are welcome to Tutor Think, and in today's video we have three separate functions to differentiate, and we are told to find the derivative of these functions. And so for the first one we have cos 3 theta minus pi over 4. So let's tackle that one first. First, what I will do is that we name the function cos 3 theta minus pi over 4. We name it by y using the variable y. So this is what we have. Then in the next step, we will differentiate y with respect to theta. We must know that in this case, we are treating theta as a variable. So if I have something like cos x, then x is the variable. And so if I have y equals cos x, then dy dx will give me minus sine x. So I differentiated y with respect to the variable x. So if I have cos theta, then I'm differentiating y with respect to what? Theta. So in this sense, we are using theta here as a variable. So we consider theta here as a variable. So therefore, when I differentiate this, we should also note before I start that pi over 4, let's assume pi is 180 degrees. So when we divide it over 4, we get a number, and that number is constant. So we assume that everything inside this part, pi over 4, we treat it as a constant. And so the differential of every constant is 0. Therefore, dy d theta will give us, then we differentiate what is inside this bracket and bring it outside. So first I'll differentiate this one, I'll get 0. So differential of 3 theta will give us 3. So I'm getting 3 outside. Then I'll differentiate cos everything, giving me minus sine into bracket the same 3 theta minus pi over 4. But we should note that if I have 3 theta, it is theta power 1. So when I differentiate this, I'm getting 3 times 1, this one, then the same theta, you reduce the power by 1, minus 1, giving us 3 theta raised to the power 0. So everything to power 0 will give us what? 1, giving us 3. So that was why I got 3 here. So now from this point, we say that dy d theta will give us minus 3 sine 3 theta minus pi over 4. And I think this is our final answer. So we can leave it here. Then we move on to the next one. Anytime I have sine squares, a variable, which is the theta is now a variable. So anytime I have sine square variable, I can rewrite it as y being equal to sine theta all squared. So from here we can apply chain rule to solve this. To make it very simple, we can apply chain rule. So what I'll do is that go through my channel, search for chain rule in differential equations. You can go over it after you are done with this work. To apply the chain rule, I need to introduce some variables. Let's say I'm using the variable u. So I'll say that let u be equal to anything inside the bracket here. So I'm getting sine theta. So now my original function becomes y giving me u all squared. Since sine theta is the same as u, I just substituted u here to get u, but the u is squared, so u all squared. Then you differentiate u with respect to theta, and you differentiate y with respect to u. So this will give us du d theta will be equal to, this will give me cos theta, because if I have sine x and I differentiate sine x, I'll get cos x. So if I have sine theta, when I differentiate, I'll get cos what? Theta. So now dy du will give us 2 times u. This is because 2 times u, and you reduce the power by 1. So this will give us 2 times u raised to the power 2 minus 1, giving us this. So now we can apply the chain rule here. We should note that we are differentiating y with respect to the variable theta. So dy d theta will give us, then what was the first thing that we spoke of? We differentiated u with respect to what? Theta. So we write that one to get du d theta multiplying the second derivative we had dy du. dy du. So we can see this and this are the same, and this equal to this. So we substitute everything we have, dy d theta being equal to, what did we get for du d theta? That was cos theta. So we can write here cos theta multiplying dy du, we had 2u, so we put it there. Alright, so dy d theta will give us 2u cos theta. But in the beginning, we said that let u be equal to sine theta. So we substitute u back into the equation, and we have dy d theta being equal to 2 sine theta cos theta. So this will give us dy d theta being equal to 2 sine theta cos theta. And this will be our final answer. From here, we tackle the third question. Let y be equal to 3 over root of 2 plus x squared. The simple way to do this is to change this to a linear function by saying that y will be equal to 3, 2 plus x squared, 1 out of 2. So change the square root to this sign. From the square root, I can write 1 out of 2. And then I can rewrite it as y being equal to 3, 2 plus x squared, negative 1 out of 2. So this is the same as if I have something like 2 plus x squared, 1 out of 2 plus x squared. I can rewrite it as 2 plus x squared, or out of negative 1. So if I put 1 over 2 here, then I'll put negative 1 out of 2 here. So that is what I did here. Now I can differentiate this function by simply saying that the derivative of y with respect to x will be, let me say, dy dx will give us, for this 3, it is already there, so we have our 3. Then we multiply it by the power, which is times negative 1 out of 2, multiplying this side, the bracket, you write the 2 plus x squared. So multiplying 2 plus x squared. Then the power is 1 out of 2, you reduce it by 1. Negative 1 out of 2, you reduce the power by 1. Then finally, you multiply the whole result by the differential of the bracket. When we differentiate 2, we get 0. And when we differentiate x squared, we will get 2x. So this is it. The rest is just adding and manipulating the function. So the first thing you need to do, you maintain this 3, you multiply the 3 by the power. So negative 1 out of 2 will come and multiply here. Then you repeat the same thing here, 2 plus x squared minus 1 over 2. You reduce the power by 1, and that was what I did. I'm just using general differentiation. Then finally, you multiply the whole result by the differential of what is in the bracket. So when we differentiate the bracket, we get 2x. So that is how we do it. So we have dy dx will be equal to minus 3 out of 2 bracket 2 plus x squared. Now you can punch everything here on the calculator to get your answer. You are going to get minus 3 out of 2 multiplying 2x. Now this can multiply this to give us dy dx being equal to minus 6x. We shouldn't forget that this one is over 1. This is sort of 1. 1 times 2 will give me the same 2. 2 times 3 will give me 6x. So out of 2, multiplying 2 plus x squared minus 3 over 2. So from here, we know this can take care of this. So we have dy dx giving us minus 3x, 2 plus x squared minus 3 out of 2. So we need to rewrite this equation. And what I'll do is that I'll remove this negative by making the function a fraction. So I'm getting dy dx will give us minus 3x multiplying 1 out of 2 plus x squared, 3 over 2. So this is it. So now I have taken care of this negative here to make the equation a fraction. So now you can also rewrite this term by changing it to the square root term. So I still can rewrite this as dy dx will give me this times this is over 1. So it is going to give me minus 3x out of 2 plus x squared multiplying 1 out of 2 times 3. Now I want to teach you something. This is indices, so when I look at this, when I multiply this by 1, I'll still get 3 out of 2. But I want to change this to square root because the question was given to me in a square root form. So now 1 out of 2 will give us the square root of this, then everything to power 3. What I'm saying is that if I have something like let's say 1 plus x all raised to the power 2 over 3, it is the same as me saying 1 plus x all raised to the power 1 out of 3 times 2. So this is the cube root of everything. So I'm getting cube root of 1 plus x all squared because there was a 2 here. So this is a general rule in indices. So I'm applying that for the function we are working with. For this function, looking at the denominator, when I separate the 3 from the x, I'm getting 1 out of 2. So I can say that dy dx will be equal to minus 3x out of 2 plus x squared all cube and then cube root of everything. This is supposed to be a square root of everything. So the final answer is what I've written. Let me rewrite this. So you make sure you go through this very carefully. You should know your indices. They are things, the rules in indices and logarithms are very, very important. You should learn them and it will help you. I hope this video has been helpful. Subscribe to this channel. My name is Daniel and see you in my next video.